Hello everyone, my name is Zoltan. In the past 6 weeks, I had the pleasure to work with London Fire Brigade on improving their employee allocation process. London Fire Brigade hardly needs any introductions. If you are living in London, then they are the ones you would call in case something caught on fire. In fact, London Fire Brigade is one of the largest firefighting organizations in the world. It employs over 5,000 employees in more than 100 stations across London. To ensure these fire stations work effectively, there are a number of very strict guidelines that set out the number of employees, their skills, and the ranks that they must have in order to be able to operate station appliances. Just imagine what would happen if firefighters arrived at the scene of a house fire just to realize that they are missing the person who's responsible for handling the breathing apparatus. To avoid such horrible mistakes, London Fire Brigade keeps up-to-date records of both station requirements and employee ranks and skills. Now, emergencies don't respect normal working hours, and so fire stations must stay operational around the clock. Firefighters achieve this by working in shifts. At the start of each shift, all employees report to their home bases. In an ideal world, every one of them would be able to make it to work, and all station requirements would be satisfied. Unfortunately, the world seldom works this way, and on most days, at least some of the firefighters will be unavailable for work. If this happens, then someone else from a different station must come in and replace them for the day. This current process is being done manually, and it takes hours to perform. So there is obviously room for improvement, and the scope of my project was to test a very specific solution to this problem. Namely, my job was to find out whether grouping stations together would help. What I mean by grouping is instead of their home bases, employees from stations that form the group would all gather at the same station. Once this is done, they would then decide who needs to stay at the station and who needs to go to the different stations within the group in order to fulfill as many station requirements as possible. And then perhaps they can just take the fire engine itself to go to their stations for the day. This process would not only reduce the number of further reallocations that have to be done across the different groups, but it would also improve employee well-being, since it would remove some of the uncertainty associated with having to work at distant, unknown stations. To test this idea, I simulated on historical attendance records what would have happened if they used grouping. Now, we actually chose to use attendance records from 2019 because I don't know about you, but for me, 2020 sure didn't look like a normal year at all. But this raised the problem because the other pieces of the data, namely the station requirements data and the employee skills and records, were from 2020. And so this meant that I had to engineer attendance records for those employees who have joined in the past year. But once I got through that, I then needed to find an algorithm that would allocate employees between stations within their group in a way that would maximize the number of station requirements that are fulfilled. So there is a fairly obvious algorithm one can think of which would do the job, which would just check all the different possible allocations of employees to the different stations within their group. But this quickly becomes unfeasible because if you want to allocate just 50 employees into 3 stations, this is a very reasonable scenario, then you would actually need to go over as many different allocations as there are stars in the universe. And even with today's modern and powerful computers, it would take you more than 1,000,000 years. So I had to come up with something more clever. And luckily, I was able to find an algorithm that works in a fraction of a second, and it gives me the optimal allocation or one very close to it. Using my algorithm, I was able to find a grouping strategy that groups stations into triplets, which could reduce the number of reallocations by an estimated 24%. The time saved by such a strategy could then be used by firefighters to train, to perform risk assessments, and conduct fire safety checks. In a sense, this would enable them to save more lives. Thank you for listening.